All right, here we're looking at 5.4, sum and difference identities. We've got three versions of a sum and difference identity. It's sine, cosine, and tangent. So when we say sum or difference, we mean adding or subtracting. So you can see in the sine sum or difference, it doesn't matter if it's the sum or the difference, plus or minus, of two terms. Okay, you can think of this as the condensed version and this is the expanded version. Just like when we did logs, we could expand and condense them. So here you have sine, and then in parentheses, what you're taking sine of is two terms being added or subtracted. We're going to call those terms u and v for the sake of our identities. Now, when you expand them, so this can be rewritten individually, taking sine and cosine of u and v. And when you do that, it becomes sine of u, cosine of v, and then that same plus or minus, whatever sign it was here, that same sign is here, then cosine of u, sine of v. So notice you have sine of u and sine of v, cosine of v, and cosine of u. The order in which you have those does matter. Okay, so cosine of u, sine of v, product in front, plus or minus, and then the product of cosine of u, sine of v. Now the cosine sum or difference formula is very similar. Okay, you have your plus or minus here with u and v, but when you expand it, notice the cosines are together. So you have cosine of u times cosine of v, and sine of u times sine of v. And then that sign in the middle, that positive or negative, notice how it's reversed. Okay, so if it's a plus in cosine, it becomes a minus in the expansion. And then if it's a minus, it becomes a plus. And then for tangent of the sum or difference of something, similar idea. But notice tangent's a fraction. So you have tangent of two terms being added or subtracted. In the numerator, you keep the sign the same as it started, but in the denominator, it's the opposite of the sign. So if it was tangent of u plus v in your numerator, you've got tangent and then you've got the plus because the sign stays the same. And then in the bottom, you're adding tangent of u and tangent of v that of each individual term. And in the denominator, it's the opposite sign, and you're multiplying tangent of u and tangent of v, and either adding or subtracting that from 1. Okay, so these are our formulas. You just are going to have to reference those. You don't obviously have to have them memorized. I'm going to just make a note here that the ones I highlighted in pink or a different color, whatever two colors you're using to highlight, is highlighted in a different color because it's the opposite sign. Okay, so then by writing angle measures as sums or differences of special angle measures, so our special angle measures, those are the ones on the unit circle that you have memorized, you can use them to identify the exact value of trig functions that are an angle that you don't have memorized. So in this example, 75 degrees. I don't know cosine at 75 degrees. I'm assuming you don't either. But 75 can be broken down into two reference angles that I do know from the unit circle. Okay, and sometimes there's going to be more than one way to break it down. Okay, so I'm going to use cosine of 30 plus 45. Okay, and I'm going to do some highlighting here to show you what we're going to replace. So I've got the formula listed here. So my u is the 30. So that's going to show up here and here. And then I've got the v is going to be the 45. So that's going to show up here and here. And this is cosine plus. So it's a cosine sum formula. So when I expand it, remember it's going to be the opposite. So it's actually going to become minus. Okay, so when I write that out, I'm going to have cosine of 30, cosine of 45, minus sine of 30 times sine of 45. And I'll highlight again to show you I did a minus there. And I had my 30 here and here for U, and my 45 here and here for V. Now I can answer all of these for individual sine or cosine functions, okay? And if you're asked what identity you're using, this is the cosine sum ID. Because in the condensed version here, you are finding the sum of 30 and 45. Even though expanded it says minus, this is the cosine sum identity. All right, so think about your unit circle, pull it out and look at it if you need to. Cosine at 30 degrees is root 3 over 2. Cosine at 45 degrees is root 2 over 2. Sine at 30 degrees is 1/2. And sine at 45 degrees is root 2 over 2. Now when you multiply fractions, multiply straight across the top, straight across the bottom. When you're multiplying radicals, you multiply what's underneath. So that becomes root 6 over 4 minus, that becomes root 2 over 4. We do have a common denominator, so we can combine these to a single fraction, but we cannot combine the numerator. You can multiply radicals by multiplying what's underneath. You can't do addition or subtraction because order of operations, it doesn't work out the same. So you would actually have to find the radicals of those first and then do your subtraction. So you leave it here because we can't simplify those. Okay, so that's our solution. All right, in example 2, this one though is in radians. So we've got a little extra step here because you don't know pi 12ths and you don't know everything as pi 12ths. So I'm going to go ahead and make a little side note here about my reference angles that I know on the unit circle in radians. And I'm going to rewrite those as 12ths. So then I can break pi 12ths down into the sum or difference of two reference angles. All right, so I've got 1/6 would be the same as 2/12. 1/4 would be the same as 3/12, etc. So that becomes 4 pi 12, and that becomes 6 pi 12. Now I can think of this as a sum or difference to get 1 pi 12. There's actually a couple of different combinations here that I could use. It's definitely going to, I'm trying to get to 1. All of these are greater than 1, so it's going to be subtraction. So I could do 4 pi 12ths minus 3 pi 12ths, 3 pi 12ths minus 2 pi 12ths. So I'm going to use that one, just the first two. Okay, so this is going to be my u and v. So I'm going to say sine, and I'm not going to write it in 12ths because I don't know it in 12ths. I know it here in pi 6ths and pi 4ths, but it's going to be the pi 4ths angle minus the pi 6th angle, the 2 pi 12ths. Okay, so that's what I'm using. I'll do my highlighting again here for you. So my u is pi 12, that's going to appear here and here. And my v is pi 6, it'll appear here and here. And my sum or difference, this is a difference, so it's going to stay the same. Remember, if it's minus, it stays minus. If it's plus, it stays plus. Okay, so this is sine of pi 4ths cosine of pi 6 minus cosine of pi 4ths sine of pi 6. Now, know your unit circle. Okay, if you're asked what identity you're using, we are using the sine difference ID. Okay, so the sign stayed the same, which was difference. Here you got my u and my v plugged in. Now I can give actual values. Sine at pi 4ths is root 2 over 2. Cosine at pi 6 is root 3 over 2. Cosine at pi 4ths is root 2 over 2. and sine at pi 6 is 1/2. Multiply straight across, and we again get root 6 over 4 and root 2 over 4, this time being subtracted. So root 6 minus root 2 all together over 4. And that's as far as we can take that one.